Hello students. So let's solve some physics numericals. Okay. The threshold frequency for a metal is F0. When a light of frequency 2F0 is incident on the metal plate, the maximum velocity of electrons emitted is V1. When the frequency of incident radiation is increased to 5F0, the maximum velocity of electrons emitted is V2. Find the ratio of V1 and V2. Okay, so whatever is given, you have to write first. So here they have given the threshold frequency for a metal. Threshold frequency is the frequency at which the electrons start emitting, right? So when a light of frequency 2F0 is incident on the metal plate, the maximum velocity of electrons is V1. Okay, this is one thing. And when the frequency of incident radiation is increased to 5F0, now this is the frequency of incident radiation. Okay, first frequency. Then it is increased to 5F0. Okay, the maximum velocity is V2. You have to find the ratio of V1 and V2. Now we have one equation, that is the energy of the incident radiation is equal to kinetic energy plus the work function. Correct? How work function is written? H nu no. That is, this is threshold frequency. Okay, and this is the frequency of the incident radiation. Correct? So first frequency of the incident radiation is given to be 2F0. So for this we can write, in place of this you have to write 2F0. This thing remains, this is F0, right? So we can write here F0. Okay. So we want the ratio of V1 upon V2. Now how we'll obtain V1 upon V2? If I substitute kinetic energy, that is half m V1 square. So here we have V1. Okay. Now I'll take this here. So this is 2HF0 minus HF0. So 2 minus 1, 1. So HF0. Okay. Now for the second incident radiation, that is frequency is 5F0. So same thing. You have to substitute here 5F0. All other things remain same, only the velocity changes to V2. Okay. So half mv2 square is equal to 5hf0 minus hf0. So this becomes 4hf0. Okay, now we want ratio of V1 and V2. So we want this in the form V1 upon V2. So if I take half mv1 square upon half mv2 square, then I'll get V1 upon V2, right? So dividing 1 and 2. So V1 square upon V2 square, we can write V1 upon V2, the whole square, 4. So V1 upon V2 is under root 1 upon 4, which is half. Correct? So the ratio is 1:2. Okay. Next question. Two resistances R and 2R are first joined in series and then in parallel. Okay. The ratio of parallel to series will be. Now we have to find resistance in series and resistance in parallel, that is total resistance. So two resistances are given. R1 is R and R2 is 2R. Okay. So total resistance in series, we have to add them. R plus 2R, which is 3R. Correct? What about parallel? Parallel we find by using the reciprocal 1 upon R plus 1 upon 2R. So here you can cross multiply or you can multiply here 2 to both numerator and denominator. Okay, so this becomes 3 upon 2R. Okay, so our total resistance in parallel is 2R upon 3. So see students, most of the time students make mistake in this. That is, they directly write our resistance in parallel as 3 upon 2R. Okay, here they may forget to write it in the reciprocal form. Okay, so be careful while writing resistance in parallel, and also in case of capacitance in series we take reciprocals, right? Okay, so we have to find the ratio of parallel to series. So parallel to series, parallel is 2R upon 3, series is 3R. So this becomes 2R upon 9R. So the ratio is 2 by 9. That is 2:9. Okay.